Santos, and this week we're going to be talking about the pH scale. So, just to recap, we need to remember or recall how we can identify an acid or a base. The first example, we have H2SO4, and if you guys look at the bottom here, kind of gives you a hint what or how to identify an acid. So the first thing we're going to do, we're going to look to see, does it start with hydrogen or does it end with hydroxide? And in this case, it starts with a hydrogen. Because it starts with a hydrogen, this is going to be an acid. I'm going to fast forward to one slide here that would help you with something like this. Just to recall from our last video, any acid will start with an H or hydrogen. A table that you can look at in your reference table is table K. That's where we have a list of the most common acids. When we're looking at bases, they end with OH. If you look at table L, you're going to see a list of the most common bases. And a final reminder is that if you have an ionic compound that does not have a hydrogen or hydroxide at the end of it, then it's likely to be a salt. So let's go back to the previous example. So here we have a hydrogen with acetate, and it starts with hydrogen. So again, this would be an acid. And this last example ends in OH or hydroxide, therefore is going to be a base. An important thing to understand about these, for example, like this first example here, this substance, when it's dissolved in a solution, we're going to have two ions form, or more like three actually. We're going to have two hydrogen ions and one SO4 ion. If we look at a base, we're going to have a calcium ion form and two hydroxide ions form. Okay, so this is what we're really looking at. The ions that are formed in the solution, when it disassociates, how do we know what's an acid or a base? So when it forms hydrogen ions, it's going to be an acid. Hydroxide, it's going to be a base. So this leads us to what a pH scale is. And the most simplest, well, not really simplest, but just the more definition of it, is a logarithmic scale that measures the acidity or alkalinity of a solution on a scale from 1 to 14. Defining certain terms here, alkalinity is a measure of the hydroxide ion in a solution. So something that's very high in alkalinity is going to be a base because it has a lot of hydroxide ions in it, or stronger concentration of hydroxide ions. Acidity, a measure of the hydronium ion concentration of a solution. So something that's acidic would be, or something that's really acidic is an acid. It's not to necessarily say that only acids have an acidity measure. Something that's a base can have a very low acidity. So in simpler terms, a scale called the pH scale has been developed to express the hydrogen ion as a number from 0 to 14. A pH of 0 is strongly acidic, a pH of 7 is neutral, and a pH of 14 is strongly basic, or more alkaline. The pH scale is a logarithmic, which means each change of a single pH unit signifies a 10-fold change in the concentration of the hydrogen ion. So what that means is, and we're going to fast forward a bit, I'm going to zoom into this down here. When we go from a pH from 0 to 1, or let's try this, from 1 to 2, 0 to 1, there's a tenfold change. So this goes on and goes on. So if I were to go from a pH of 1 to a pH of 2, and we're looking at the hydrogen ion concentration, which, by the way, as it go from 0 to 14, it decreases, okay? We can say that it decreases by, and if we're looking at 1 to 2, by tenfold. If we're looking at a pH of 1 to a pH of 3, so it's going from here to here, 10 times 10 is 100, so it'd be 100-fold. Okay? So this is looking at, again, decrease, because it is decreasing, because you're increasing in numbers. If we're looking at the OH concentration, as you go from 0 to 14, it's actually increasing. So if it says OH concentration and you're looking at a pH of 1 to a pH of 3, the concentration of OH is increasing by 100-fold. The concentration of the hydroxide ion increases by 100-fold. Okay, hope that makes sense. Let me erase this down here because I kind of want to, oh, now we're done. So when we're talking about an acid, as you go lower, as you go from 14 to 0, the concentration is increasing. So for hydrogen, it's increasing going this way. Okay, so as you go down the number scale, it's becoming more acidic, therefore the hydrogen concentration is increasing. As you go up the number scale, the hydroxide ion is increasing and is becoming more acidic. Okay, so it's pretty much doing the opposite. As you become more of an acid, going this way, hydrogen concentration increases, hydroxide decreases. For a base, hydrogen concentration decreases, hydroxide concentration increases. And when we hit a neutral 7, they're actually equal. Okay? So those are two things you need to know when we're going the concentration increase, so it's 10-fold, 100-fold, 1,000-fold, or also knowing how to compare the two concentrations. Okay, so let's take a look at the next slide. So here are the common substances and their pH levels. HCl, which is a common acid we use in lab, and sodium hydroxide, which is a common base we use also in lab, or that you've used in lab. And as you can see here, our neutral concentration has an equal concentration of hydrogen ion and hydroxide ion. A lot of these things are seen in your home. For example, lemon juice and vinegar also soda, are very acidic, or bleach and ammonia, stuff that we use to clean our home, which is very basic. To look at everything combined, we can look at the pH scales, which is right here, and look at the concentrations. And again, if you guys notice, as we go from 0 to 14 in our pH scale, our hydrogen ion concentration decreases. It becomes smaller. When we look at the hydroxide concentration, it increases or becomes stronger, more concentrated. Okay. And these numbers kind of help you see that the difference between the pHs is a tenfold for each. All right, so let's take a look at some examples. Which relationship is present in a solution that has a pH of 7? If you guys recall from earlier, the pH, the concentration of the hydrogen ion and the hydroxide ion is going to be equivalent here. So your answer would be A. When we look at these here, when something has a high concentration of hydrogen but low concentration of hydroxide ion, it's going to be an acid. While when you have a low concentration of hydroxide and hydrogen ion and a high concentration of hydroxide, is going to be a base. Which leads us to this question right here. So this one is asking you to look at a pH of 1. So for a pH of 1 means that it's an acid, and an acid has a high concentration of hydrogen ions and a low concentration of hydroxide. So the answer here would be B. Let's do one more similar to this one. Now we're looking at a pH of 10 instead. So that means this is a base. So a base, again, if you guys remember, it will be a salt that has an ending with OH. So it'll be like NaOH. Oops, forgot the A. Or CA, calcium hydroxide. Okay. And they all have hydroxide ions in it. So obviously it's going to have a bigger concentration of hydroxide ions and a low concentration of hydrogen ions. Think of it almost as a scale, if that helps. Which of the following pH values indicate the highest concentration of hydronium ion? So hydronium ions is going to work just like the hydrogen ion, because our acids have or form hydronium ion. So it would mean that you would need an acid, and the smaller the number, the stronger the acid. So that would be A. 3 is the most acidic out of all. So let's look at the next one. So this one is talking again about hydronium concentration, and it wants to know which solution has the highest pH. So a trick that I've learned is if you count the decimal places after the period, that would tell you the pH. So this one is a pH of 2. And again, this only works really for Regents chemistry. When we're looking at stuff like this, it becomes a little bit more difficult when you start adding different numbers. This one is a pH of 3. 1, 2, 3, 4. This is a pH of 4. 1, 2, 3, 4, 5. And this is a pH of 5. Okay, so keep in mind these numbers here. And I'm going to go back to our chart from earlier. So we looked at this one, 0.01. That's a pH of 2. And let's verify what I got here. 0.01, pH of 2. And let's look at this one, 0.00001, 0.00001. So it matches, okay? So again, it's not really math behind that one. It's really just a trick that I learned to do without math. But when we're looking at the concentration, it's really just 1 times 10 to the negative 2 for something like this, for a pH of 2. And when you do the antilog of this, you get 2. And that's how you know that's the pH. And that's really the math behind that one. So back to the question when it says, which solution has the highest pH? The highest pH is the higher number. In this case, it would be pH 5, so it would be D. And in this one, a lower pH would be this one right here. It would be A. So again, this is going based off of the pH scale we looked at. This question is comparing an aqueous solution with a pH of 6 to a pH of 8. So the pH of 8 would have higher OH or hydroxide ion and lower hydrogen ion, while a pH of 6 will have a not super low but just a little bit lower OH than 8, but a higher H concentration or hydrogen concentration than pH of 8. So they want to know, and one of the key things here is that they all say more. Okay, so because 8 is higher than 6, we're going to be looking at the hydroxide ion. Because as you go up the pH scale, hydroxide ions are the ones that are increasing. And we're comparing 6 to 8. So keep in mind that there is pH of 7 in between them. And as we go from a pH of 6 to a pH of 7, the hydroxide concentration is increasing by 10-fold. So that means when we go from 6 to 8, it's going to be by 100-fold. Okay? So this one is going to be D. Okay? Let's take a look at the next one. Over here. This one is comparing a pH of 1 to a pH of 3. Okay? The pH of 1 will have, and now again, these all say more. So remember, when you go down the pH scale, so 14 to 1, hydrogen is increasing, and so is hydronium. So H3O is higher here than it is here. And so that means it has to be A or B. And if we were to look at hydroxide, hydroxide is actually higher here than it is here. So that's why we can't choose C or D. Now, if it said less, then we could, because this one has less, pH 1 has less hydroxide than pH 3. But we're looking at hydronium, and it says that the hydronium concentration is higher in pH 1 than it is in pH 3. But we want to know by how much, and we know that between pH 1 and pH 3 is pH 2, and I'm sorry, these look like capital, but they're supposed to be lowercase. It's supposed to look like this. So as we go from pH 3 to pH 1, it's less by, or for hydronium, is more by 10-fold. 10-fold. Okay, so again, that means that it would be 100-fold. Okay, so I hope that makes sense. If you have any questions, feel free to reach out to me. Definitely this right here helps. Okay, And just to summarize, just remember that as we go up the pH scale, our hydroxide ion concentration increases. As we go down the pH scale, meaning from 14 to 0, our hydrogen ion increases. Oh, that came out crooked, I'm sorry. And also our hydronium. All right, I hope that was helpful, and I hope you guys have a great day.